Start.
Good evening. Our topic is microservices using Docker and Kubernetes and its comparison with monolithic architecture. Monolithic architecture. It is a traditional, unified, self-contained design for software program, which is difficult to use as it is difficult to make changes in it and it is difficult to scale and has large size and thus can be slow. In our project, we have used the JavaScript nodes and four endpoints are used: orders, their IDs, products and their IDs, and we have deployed it on a virtual machine with 2 GB RAM and two dedicated CPU cores. Microservice architecture. Microservice architecture is a more recent cloud native approach in which a single application is composed of many loosely coupled and independently deployable smaller components. In our project, we have used microservices, which consist of breaking up of the previous monoliths we used into two parts. One is the product service and other the order service. We are still using the JavaScript nodes as we want to keep the miscellaneous factors affecting our testing to be minimized between microservices and monolithic services. Now Deepak will carry it on.
How have we deployed the microservice applications? And the answer is we use containers. Next. Containers and microservices enable developers to build and manage self-healing microservice-based application more easily. While the two terms aren't the same thing, in reality, containers and microservices are often used in same sentence. Docker container is a set of platform as a service software which uses OS level virtualization to run applications independently and isolated. Next. We have created Docker image of individual services using Docker files and pushed these images to a public repository on Docker Hub. Next. Now Parkavi will continue.
So now how will we manage all these containers? So for that we use Kubernetes, which is an open source software for automating deployment, scaling, and managing the containerized applications. So basically in this we can group containers to make an application into a logical unit. So this way it is easier for us to manage and discover. Next, we can also we can also use this these Kubernetes clusters can span host across on-premise, public, private, and hybrid clouds. For this reason, Kubernetes is an ideal platform for hosting cloud native applications that require rapid scaling, like real-time data streaming through Apache. So another orchestration to do the same is Docker Swarm, but we chose this because of the scale of production. Uh, for this, we for both the services we have created Kubernetes deployments and the services file. The following are the commands to access them. And one of the major benefits in this is that the YAML files have already been made, and you need not do it every time for every new cluster. So I would like Vishal to continue.
So for load testing of the applications, we tested both the monolithic application and the microservices application using JMeter. Apache JMeter is an Apache product that can be used as a load testing tool for analyzing and measuring the performance of a variety of services with a focus on web applications. Next. So our test plan consisted of scaling from 1 user to up to 10,000 users concurrently. These tests we ran in multiple we obtained stable results as shown in the next slide. Next. So during low load testing, we used concurrently 1 user, 10 users, and 400 users. And as you can see, the results are at par with each other. In monolithic services, the average response time for 100 users is 13 milliseconds, whereas in microservices application it's 12 milliseconds. And the standard deviation for monolithic is 9.75, whereas in microservices it's 8.5. And we can also compare the minimum and maximum response time. For 100 users in monolithic applications, its maximum response time is 96 milliseconds, whereas in microservices, its maximum response time is 98 milliseconds. So from our testing, we can observe that lower the load, greater does the container overhead affect the performance of the microservices application. Now, Paul will continue.
So we further did our load testing on moderate loads, which were 200, 500, 800 users concurrently. In this case, also, we didn't receive any error cases like either of the application failing or anything. We still only saw performance differences. There were no failures. And here we noticed that as the users grew, the benefits of microservices started to shine a bit more. Like initially in 200 users, still the difference is quite low, but we can see that the standard deviation has reduced. We can see that concurrent calls are becoming more stable. There isn't much fluctuation in the at least lower fluctuation in the response times. Where in 500 users, we can see that the time of response has also greatly decreased, and the standard deviation too has reduced. And same we can see in 800 users. Like it's almost a third the response time, and also the standard deviation is very low, corresponding to the users. So here we can see that because of the replicating nature of Kubernetes, like if we want to replicate, there's an option to, like as we have done in our application, the microservices are running on 8 replicas, each each service. So those multiple replicas allow it to be better for higher loads if we are running on a single machine, like, without any multiple machines or virtual machines. And high load. Next, we did high load testing, where we just tried out with 5,000 users and 10,000 users. We couldn't test above 10,000 users because of the limits of our own personal laptops. Here again, we see that microservices outshone monolithic applications, like simply based on the fact that they're microservices, because our applications were actually very similar. It was just the deployment factor which was the major difference in the two. Here again, we can see that the response time is very low relative to monolithic, and also it's much more stable, the response time. And again, it's the same reason. Like we can see that the replicating nature of Kubernetes. And again, at these levels of users, we did notice some errors popping up. Again, but in microservices, still there was zero errors. Maybe if we went on to more high users in our local testing, we could have achieved some errors. But until now, we got zero errors from microservices and a 19.4% errors from 10,000 users and 0.75 failure from when we tried 5,000 concurrent users accessing the endpoints. So to conclude, what I would say that other than the textbook definitions and the theory behind microservices and monolithic, that it's easy to develop, it's easy to deploy, uh, the fact that we don't have to do much changes to move it from cloud to cloud, like we're not bound to any single cloud. We can also see that the performance bonus of microservices in most cases is better than monolithic applications, especially at larger loads. And of course, in production level, it's mostly larger loads, which is the problem and the issue. Lower loads is most of the time actually quite simple. And again, in what differs it from monolithic is it's also easy to deploy, and it's quite quickly to deploy microservice applications, and it's also scalable. So next, I would just like to show a small demo of what we have. So first of all, we have a Kubernetes dashboard which show the deployments. So for simplicity's sake, I've added the monolithic 2 to a Kubernetes dashboard right now, to a Docker image. But the testing was based on installation on the virtual machine of 2 GB RAM and 2 CPU cores. And these deployments are all, this Kubernetes is also running on the same specification. And here we have the individual pods. As we can see, we have 8 pods of orders and 8 pods of products, the microservices. And here, for now, I've only added one single pod of monoliths. And yeah, we can also see the terminal view for that. Here we can see the monolith orders, monolith service, order service, and product service. And here we have the endpoints which were available. They're available from both of the services, so it doesn't make sense to show them twice. So here we have the get orders where we just have the list of orders. We have a single order by calling the ID. We have multiple products, and we have the single product over here. And we did our load testing with JMeter, where we had 4 HTTP requests, all calling the different endpoints. And we could basically see the result of each test in the summary report. Right now, it's clear because it refreshes itself after every restart. So yeah, that was a project, and that's all from my side. Thank you, everyone. Okay, बात बंद कर दे.